Welcome, everyone. We'll get started here shortly. We'll let the room fill up just for a few more seconds. Thank you. All right. It looks like we've reached that level, so we'll go ahead and get started. Thanks again for joining. There is a term thrown around all the time about IAQ. It usually is synopsis. It goes right along with IAQ. It's the sick home syndrome. So sick home syndrome is just a phrase that describes situations in the structures occupants experience acute adverse health effects and or discomfort that appear to be linked to spending time within the structure, not specifically to an illness. It can be caused by poor indoor air quality linked to little or no ventilation. And of course, as we talked about on the previous slide, symptoms include asthma, respiratory ailments, rash, nausea, dizziness, and headaches as well. So the poster on the right shows kind of it's addressing the adverse effects of the building when you're building a tighter home. So we always preach, and I always preach, energy efficiency. It goes hand in hand with energy efficiency. As the tighter the home is, the longer the air is in place and doesn't have to be reconditioned. So it is more energy efficient. It doesn't use as much energy to condition the home over and over and over again. But the result of that is you're trapping pollutants inside the house. You may have a really tight HVAC system, but what you're doing is distributing and circulating the pollutants that are inside the home to other parts of the house. So if you have CO in one room, if you have a return near there, it's pulling that contamination in and then circulating it through the home. And it's not really going anywhere, it's just trapped. So diluting that air or removing that pollutants is going to be the goal for mechanical ventilation. So just common pollutants, we talked a little about those a second ago, but you've got VOCs, which is the volatile organic compounds. Those are organic chemicals that are easily evaporate into a room at room temperature. So paints, varnishes, cleaning supplies, building materials. The effects of just VOCs is eye, nose, and ear and throat. Throat and eye irritation, headaches, nausea, long-term damage to liver, kidney, and nervous systems. Then you've got mold and mildew. It's just fungi that thrive on moist environments. Sources of that is high humidity areas, leaky pipes, areas with water intrusion. And then health effects for that is allergic reactions, asthma attacks, respiratory issues, and in some severe cases, you've got lung infections as well. And you've got dust mites and pet dander. So those are microorganisms in dust and small particles from pets. They pick some of these things up from outside, bring it inside, and then they shake and move around and throw those into the air. They can be found in the beddings, the upholstery of the furniture, the carpet, and then impacts from that is allergies, asthma, and then respiratory irritations as well. And then CO, carbon monoxide, it's colorless, it's odorless, it's tasteless. You won't know it's actually there. It's produced by burning or the improper burning of combustible fuels. Sources of that is gas stoves, furnaces, fireplaces, and vehicles as well. Impacts for that is headaches, dizziness, weakness, nausea, and at high levels, it can be deadly. So sources of these, the sources of the common ones that we see and where they're coming from, you got emissions from new building materials. So what can happen from that or where it can come from is VOCs, formaldehyde, and other chemicals. Thankfully, formaldehyde has been on the out for a while. A lot of the products are not being used with that, but there may be some products that homeowners purchase after they've occupied the building. And we look at it and say, well, that's kind of their issue because they've purchased it. However, code dictates that we look at it from the life of the building. It's the useful life of the building or structure. So if it's going to trap anything and they buy things in the future, it can trap these things in the house. And if ventilation is not done properly, it can lead to health problems. And it's the fact that we're looking at it from a long-term building structure, not just snapshot in time when you look at it from the time of inspection. So lack of adequate ventilation, so tighter homes trap pollutants. You've got limited natural airflow that leads to the accumulation. Solutions to that: start installing mechanical ventilation, using air purifiers, and then of course airing out the homes as well. So HVAC systems and ductwork. So contributing to that is airborne pollutants could get passed around through the house by being distributed through the HVAC system. It's the accumulation of dust and mold and other allergens inside ducts and filters. So if you haven't seen what the inside of an old duct system looks like, a lot of times there's a lot of dust accumulation, but on that dust are dust mites, and there's also chances of, if there's condensation buildup in it or high humidity, it can actually condensate inside those ducts and build up mold as well. So there can be a lot of things that are adding to allergens inside the duct system. So preventative measures from that is basically regular HVAC maintenance, cleaning of ductwork, and then of course using high quality air filters as well. Other potential sources is household cleaning products. We've talked about that a little bit in the past. Is if you can smell it, it's got some pollutants in it. There's contamination of some sort. It may not be harmful for you, but it may be harmful for someone else that's near you or also occupying the house as well. So anytime you see that, if you wash dishes, if you do the laundry, if you put those little pods in the dishwasher, that actually just opens up that and puts it into the air, into the environment, that leads to chemicals and VOCs in the room. I mean, they may be very low, they may be very low VOCs. They'll dissipate over a short amount of time, but others linger for a long amount of time. Personal care products also contribute. So aerosols, any type of perfume, colognes, hairspray, things like that, those usually dissipate pretty quickly. A lot of the contaminants that were in that have been outlawed and not used in those cans anymore. But cooking can also produce carbon monoxide and particulate matter as well, that gets airborne. So that's just some of the sources of where this actually can come from. Health impacts, we've already talked about that just a little bit, but you've got immediate effects, long-term effects, and then with vulnerable groups that we have. So immediate effects is eye irritation, nose and throat. So if you start coughing from it, if you're wheezing, if your eyes start burning, just realize that's an immediate effect, but there is still long-term effects that could be playing a role in that. So you've got irritation of nose, throat, headaches, dizziness, fatigue, nausea. Long-term effects is respiratory diseases, heart disease, cancer. The vulnerable groups that they look at is children, the elderly, people with asthma, already having a chronic issue that actually could have a problem when you lead and have a more higher contaminated home. Higher parts per million of a product could lead to or exacerbate the chronic respiratory issue or even a cardiac condition as well. So these are things that you look at when you're talking about IAQ. So code and building regulations now address indoor air pollutants by requiring adequate ventilation. So a lot of this role in the building codes is just to establish a minimum requirement for the health and safety of the building conditions and the occupants inside. It's now listed in the IBC, the IRC, the IMC, and now in the IECC as well. So standards for those ventilation, usually all of these come from, in the I codes, it comes from the ASHRAE standards. So it's the 62.1 and 62.2 is the ASHRAE standard. They give key guidelines for ensuring adequate air exchange and or reducing pollutant concentration. Other standards like Energy Star, LEED, the Leadership in Energy and Environmental Design, and also WELL Building Standard, and the SCS Global Standards, as well as another one called Green Guard, is out there to actually be able to look at and determine if you have a sick home syndrome that's happening with the indoor air quality being poor, and or things that are being trapped inside the contamination of the house and not being vented properly. So I know when I did inspections a lot of builders would look at it from, we want to build a tight house, but now we want to punch a hole and we want to actually call that mechanical ventilation. And now it doesn't make sense. Why are we going to build a tight house and not allow the house to breathe? Why are we going to build a tight house and then punch a hole in the outside? And the answer to that is we want to control how much and when. So it's not uncontrolled contaminations or humidity or temperature coming in and out of the building. We're going to conserve energy by trapping everything, but now we're going to make sure mechanical ventilation is there to either dilute or exhaust the contamination inside the house. So before, all the homes were required before they were all required to be below 5 air changes per hour by the code. A home was usually tested by a blower door to determine the need of mechanical ventilation. So in 2009, you could pass the code by just doing 7 air changes per hour. If you did a blower door test, you didn't have to do any inspections. You just tested it for air tightness. That really wasn't tight enough to cause an issue with contamination. But once it reached that level of 5 ACH, it really deals with natural ventilation in the home, and it's a certain natural, but it kind of equates to that 5 ACH. Now that code is asking for it to be at or below 5 ACH, now it brings in mechanical ventilation is now required in all climate zones. So with this, it's just buildings complying with section R 402.4.1, which is the blower door testing requirements, shall be provided with ventilation that complies with the requirements of section M1505 of the International Residential Code or the International Mechanical Code as applicable, or other means, approved means of ventilation that's approved by the code official. So if you can have them understand that opening and closing windows in the house is an approved method of ventilation, that's an approved method by the code official. Most code officials now want to follow what it says in the code, then actually be able to, again, it's for the life of the building. It's not the occupant occupying the house now. They may be somebody that goes in and out a lot, but the next homeowner may be retired and doesn't go in and out of the house a lot, which means you're going to have to set the house up for its worst case situation, which would be trapping pollutants and having that mechanical ventilation. So outdoor air intakes and exhaust shall have an automatic or gravity damper that closes when ventilation system is not operating. We've talked about this before in previous slides. Even though mechanical ventilation is now required, the code also now dictates that the fan system being used to draw air in or out must also be energy efficient. So this table shows the different types of mechanical ventilation. We've looked at it before in the past. It's the efficacy requirements of each of those systems. So we've got ERV, HRV, inline supply and exhaust fan, which is new to the code because that's a little arrow that's pointing there. It's new to 21. I took this out of the 21 code book. But then the other exhaust fan listed there, and then the air handler has been in the code for a little while. But it just talks about what's actually allowed, minimum efficacy. So it's by efficacy, that means the amount of airflow or CFM produced must be done at a low energy consumption. So it's using very low wattage to pull in that very low amount of CFM or airflow. So as we see on this table, we got different fans that show different requirements of efficacy. So these little inline boxes we've seen in the past on other webinars, basically any airflow that it's drawing, it needs to at least meet a 3.8 CFM per watt allowable minimal efficacy. But if it's being used on the air handler and it's a 6-inch duct tied to a return plenum and it's using the air handler as its fan source, then any CFM rated for that needs to hit a 1.2 CFM per watt. So that's really low, and the majority of the time when you do a performance model, the air handler will fail in the performance model because of the fact that it's too much energy being consumed for such little airflow. So that's where it comes in to say, a lot of times third parties will tell the builders you cannot use the mechanical, you cannot use the air handler as your fan source because it will fail the model. If you go prescriptive, as long as it's an ECM motor, electrically commutated motor, then it can be used as part of mechanical ventilation. But if you're using performance or ERI, it's going to basically the software is going to fail that model because it's using too much energy for the air handler being used. So lastly on this, we got mechanical ventilation is now required to be tested in 21, but in the 12 and the 15 and the 18, they just had to have mechanical ventilation. So when I did the inspections, it could have had all the components, but they didn't function. Or it had all the components and very little airflow is going in and out. It may be less than 10, but it still technically complied with code. Now in 21 and beyond, it must also be tested to prove functionality and proper airflow. So with this, mechanical ventilation shall be tested and verified to provide a minimum airflow required in the section before that we just saw on the table. A written report of the results of the test shall be signed by the party conducting the test and provided to the code official. That's usually now on your final CEO form or a CO form. When the builder has to turn that CO form in, it'll have what's the tested results for mechanical ventilation. So if you're in a city that's using an older form from 12, 15, or 18, and you have not updated that form to require the number of tested result for mechanical ventilation, I ask you to try to go back and do that, because we need to have that recorded that it actually has been tested per the code requirements. So proper airflow mechanical ventilation can be determined in two different ways. We've talked about it before. One is this table. So two is actually doing the calculation, which is the ASHRAE 62.2, which I don't show here, but it's using 1 CFM per total square foot area plus 7.5 CFM per person. That's kind of making up that what is now allowed for, or what is the minimum mechanical ventilation that needs to be done. So the proper airflow on using this table, when you have either method, the requirement for that says it's to not be less than the calculated CFM or the CFM listed on this table. In other words, when the system is being tested, the CFM reading should be at or above the listed calculated ventilation rate. The only problem I have with that, which is not yet addressed in the code, is in our warm and humid climates, there is no requirement or limit set on what is too much. So if you have an air handler being used as its fan source, you've got a 6-inch duct and the damper just opens and closes every time the unit runs. Well, when it's running in the winter, it's drier air outside, but when it's running consistently in cooling, if it runs long enough, it should pull humidity out. But really what it's doing is pulling uncontrolled humidity through there. Those systems can run without conditioning. So it's just the fan turning and it's pulling outside air in. It could be 100% humidity, and that's what's being pushed into the home. So with that, sometimes that can lead to additional problems because you have a tight home, you're building up humidity. We're seeing this a lot in foam houses and or just homes being built a lot tighter. It's building up more humidity inside the house, which leads to additional problems that we'll discuss later in the webinar. But in the Energy Star program, its tested CFM must be between 15 CFM or 15% plus or minus of the target, which basically keeps humidity in check. So I like to see that. I hope eventually in the future versions of code this will be addressed, because as well as in the coming slides, you'll see moisture is also a concern when it comes to indoor air quality and having good indoor air quality. This table, of course, just shows a range of what's required. This is, the top one is 24/7, 365 days a year. It's running all the time. The one at the bottom actually just shows, well, if it doesn't run all the time, then I need a multiplier to actually get that tested number up higher to where I'll be testing it. So if I'm looking at it and it runs 15 minutes out of the hour, then I multiply it times 4. So if my requirement is 75, you're multiplying that times 4, and you're going to test it at like 300 instead of 75, because that would be too low if it's only running 25% of the time. With third parties, most of you guys, if you're testing it now and you're able to adjust it, if it's supposed to get 75 and you test it and you're getting 150, well, then you basically turn the run time down to 50%, half the time, 30 minutes out of every hour. But not all systems allow you to do that. There are exceptions to talk about, so just worthy of noting here is, one is called now a ventilation rate credit. So with that ventilation rate credit, the minimum mechanical ventilation rate determined by the table we just saw, or the equation of ASHRAE 62.2, can be reduced by 30%, provided that both of the following conditions apply. A ducted system supplies ventilation directly to each bedroom and to one or more of the following areas: living room, dining room, kitchen. So when they take a standalone fan or just a 6-inch duct and they dump it into the return plenum, and you've got a standalone fan that dumps into the return plenum, you're meeting 1.1 because it's distributed throughout your duct system, which it's going to every single one of those rooms. So you meet that. But it comes down to the next one. The whole house ventilation system is balanced ventilation system, which means you're pulling air out at the same time you're pushing air in, or you're pushing air in at the same time you're pulling air out. Those are ERVs or hybrids. We don't normally see that in what they install because those are too expensive. So what we normally see is an exhaust only or a supply only We don't normally ever see a balance. So now that excludes that, and they can't get the ventilation credit, which means now they don't take the 30% reduction. They need to hit what it shows in the table or what's calculated by 62.2. So as I said a second ago, just 95% of all those systems we can see in Texas don't meet 1.2. And then the second we have is with programmed intermittent operation. So the system is permitted to operate intermittently if the system has controls that operate not less than 25% of each 4-hour segment and meet the ventilation rate on the previous table, or by the equation of the ASHRAE 62.2. Those little standalone boxes and or the Y8150s from Honeywell, those can run at intermittent operations. What just has to be determined is it running 25% out of each 4-minute segment or 4-hour segment of the day? If not, it doesn't meet that requirement. They can't take that reduction as well. So ventilation IAQ, just going through that, what's the role of ventilation when it comes to maintaining indoor air quality? So we just went through some of that. But it's just ventilation helps dilute and or remove indoor pollutants. So it's more important in tightly sealed homes like what's in modern day houses built to code. The impact of that, it can lower moisture levels to prevent mold growth. I know we just talked about if it's uncontrolled or not tested and set properly, you can get too much humidity and it can raise the potential of mold growth. However, if it's done correctly, you can prevent and lower the levels of potential mold growth by controlling moisture. So you do have natural versus mechanical ventilation. You've got natural being windows, doors, vents, energy efficiency. They're energy efficient by using natural airflow, but they're less controllable to the amount of airflow and humidity coming in and out. So we say, yeah, you can open and close windows. I get it, I understand it. You could use that as to say, can't I use that as part of my strategy? Yeah, you might be able to, but the problem comes down to it's uncontrolled and you don't know how much you're actually having. So is it adequate? You don't know. Mechanical ventilation or mechanical side of that is just exhaust supply balanced, or I've now put on here a hybrid system. There is companies out there that do make hybrid systems that is just a supply or an exhaust only, but it has an additional controller that can control bath fans or kitchen exhaust to actually balance the home itself. So when it comes on and it's pushing air in the home, it'll also exhaust air at the same time, allowing it to be a balanced system, a hybrid ERV, if you would. But these can be controlled. They're way more consistent. They use a ton of less energy by comparison to the air handler. They do require maintenance, and there are higher installation costs. And that's agreed by everybody that yes, it does add to installation costs, but it's better for the house to do it that way, and it's less energy consumption. So in the long term, it's going to pay for itself in a relatively short amount of time compared to using an air handler as its fan source. Recommended rates that you'll see out there, it says 0.35 air changes per hour natural, but not less than 15 CFM per person. But a while ago we saw the 62.2 is 7.5 per person, but then you're adding 1 CFM per conditioned floor area, where here it just says if you're not looking at that, at least 15 CFM per person needed. And then intermittent exchange, exhaust and condition bathrooms and kitchens. You can do an air changes per hour calculation on kitchens and bathrooms to see if the rated CFM on the bath fan is pulling a 0.35 air changes per hour or better, giving you that exchange of air that you need. And then specifically needed for homes with fuel burning appliances and fireplaces. So the tighter the house is, the more chances you have of decompressing the home by having bath fans or kitchen exhaust run, and you're depressurizing the home itself. So when that happens, you have a potential of pulling contaminants down the flue pipe. So having exchanges or ventilation that can help offset that is key into some of this. We've talked about this before. I'm not going to go through every single one and show pictures of that, but there are different types of mechanical ventilation. We just talked about natural, just opening windows and doors, not reliable, can't really calculate to how much ventilation is actually happening. Then you have exhaust only. These systems, they work by depressurizing the house. They remove air from the home, and as a result, the outdoor air is drawn through leaks in the house. So outdoor air will be sucked into the walls, That's why in the warm, humid parts of the country, you don't want to use an exhaust only system. For those components, you can usually use bath fans, kitchen exhaust, a dedicated exhaust fan. But kitchen exhaust can be tied into that. They're real suitable for colder climates, more dry climates, like to the west of DFW in Texas and San Antonio, west of that, and anything that's colder than that. So without entering moisture and condensation problems inside the house, they're limited. They're limited to cause issues in combustion appliances by depressurizing. We just talked about that. You risk the possibility of pulling contaminants down a flue pipe if you depressurize the home. Supply only. These are normally, you pressurize the house, it blows a little bit of air to the outside, and it kind of blows air into the walls or through those leaks. You're losing a little bit of conditioned air, but you're not sucking humidity and temperature through the walls and through the leaks inside the building's envelope. You're actually pulling a little bit of air from outside into the building. It pressurizes it and pushes it through the wall. It consists of a fan and a duct system. It's often included in a filter to filter the clean air, or it's pushed into the return plenum. It's better suited for hot, humid, or mixed climates like DFW and east and then southeast part of the country. It may bring in pollutants and humidity and require appropriate filtering and dehumidification systems. This is what we're fighting kind of in Texas, is it's pulling in humidity, and now you got to turn around and dehumidify because it's adding humidity into the home. So balance systems like an ERV and an HRV. Like I said, I broke this into two because now there are hybrid systems, not just an ERV or HRV. But those provide equal amount of intake and outtake to balance the air. They're consistent of two fans or one fan that has several ducts running through it. They bring in fresh air and expel some of the stale air or pollutants. They're effective in all climates, provided they control ventilation while minimizing energy loss. And then higher installation and operational costs compared to other systems. These are maintenance hogs when you talk about ERVs and HRVs, but ERVs can transfer heat and moisture between incoming and outgoing air streams. They benefit by maintaining the humidity levels. So it can remove humidity before the air gets in by crossing over the air streams, not mixing it, but crossing it over by a medium. It can reduce that humidity and actually go down a condensate drain. So particularly useful in climates where humidity control is necessary. And then of course in HRVs, the same thing. It just has a heater in it that actually can heat the air a little bit higher before it actually gets pushed into the home. So commodities to all of these, both of these systems are energy efficient. They have energy recoveries. They reduce heating and cooling costs, but they're more complex. There's more maintenance. If the homeowner is not told about these maintenance, it could possibly fail prematurely. So each type of these mechanical ventilation system offers unique benefit and is suited to specific climate conditions and building requirements. For ERVs and HRVs, climate zones 7 and 8 now are required to have ERVs or HRVs, and now in 2024, I think they're adding climate zone 6 to that. So those are mandatory requirement for having that equipment, but further down in the south, you don't have to have an ERV or HRV. So the choice of these systems could be based on specific building needs, considering factors like climate, air quality concerns, and then the energy efficiency goals of the home itself. So we talked about a little bit that moisture is also a concern when it comes to indoor air quality. It can deteriorate the indoor air quality in several different ways. You've got mold and mildew growth, so the higher humidity can create an ideal environment for mold and mildew to thrive. These fungi release spores and toxins into the air, which can cause a range of health problems. So increased allergies, you got dust mites, common allergies can thrive on humid environments. So you're causing kind of more of a breeding ground of those kind of things. But VOC concentration. So if you've got VOC emitting from paints and solvents and other products, can be more prevalent in humid conditions. So higher humidity can increase the off-gassing rate of these compounds, leading to higher indoor concentrations and potential health risks. This one was one I didn't know before doing the research for this webinar, is you increase humidity, you increase temperatures, the off-gassing also increases. So it's not a steady stream of off-gassing just because of the product or chemical involved. It's also determining on its environment it's in and its surrounding temperature and humidity levels. So chemical reactions, humidity also can interact with certain pollutants, leading to chemical reactions that produce new airborne contaminations. So for instance, ozone can react with indoor pollutants in humid conditions to form harmful byproducts. That was a new one for me. I didn't realize that again, humidity plays that much role in it. I always thought it was mold and mildew and increased allergies, but I didn't realize the chemical reactions and the VOC reactions when it comes to higher humidity. So comfort and health. So higher humidity can be an indoor environment, make it feel stuffy and uncomfortable, exacerbating the conditions like heat exhaustions or heat stroke, and also aggravate the skin conditions or respiratory problems. It can also, and what we look at from the building standpoint, is excessive moisture can damage building materials, leading to structural problems like paint peeling, wood warping, metal to corrode, further contributing to indoor quality, air quality issues by those damaging materials now release additional pollutants. So therefore, maintaining optimal humidity levels, generally recommended is 30 to 50%, is crucial for sustaining good indoor air quality and ensuring health and comfortable living environment in the home. So those were kind of some new things for me to look at and say, well, I didn't realize that had something to do with it, and it was direct correlation to that. So that was interesting to see. So air infiltration systems, another step in maintaining indoor air quality is air infiltration systems or filter systems in the HVAC. So here are a few types of different air filter systems, and we look at each one of those in their purpose, which you have HEPA filters, which is the high efficiency particulate air filters. These can trap up to 99.97% of particles down to 0.3 microns in size. They're ideal for removing fine particles like pollen, pet dander, dust mites, tobacco smoke. And then you also now have activated carbon. So those are harder to find. I think most of those you'll have to order them online. They may have some in the big box stores. But these are used to absorb gases and odors not captured by the HEPA filter. So trapping VOCs and smoke and various household odors. So using a HEPA and an activated charcoal or activated carbon in conjunction with each other, you're now, you've got two bats and one stone that you're hitting there. You're taking care of everything at one time. But then you have electrostatic filters. Those used to be more popular in the past. I don't really see a lot of these. I think you can order a lot of them online. I used to sell these exact filters that you see here, that metal frame. Basically what it is, it's electrically charged media filter that attract and trap particles. Most of these that you see that are washable and reusable, they're basically, as you see in this little picture, it's a self-recharging or self-charging electrostatic fibers. So it's not powered by anything. You don't have to plug it into anything. It basically self-charges as particles go through it. It actually will self-charge. And then you have the UV filters. So it uses ultraviolet light to neutralize bacteria, viruses, and mold spores. Often these are in conjunction with the filter type. So you'll put this into, or those lights that you see there, they're punched into the supply plenum, and or you could put it directly into where the coil is, and you're killing a lot of those bacteria and viruses and mold spores before they make it into the house. So that's a good way to do that. And again, using some of these in conjunction with each other, you now have got a multiple layer of defense for the house itself. So role in moving particulates and contaminants, particle filtration, how different filters capture different sizes of particles. Then you've got gas and odor removal. So now you can use carbon. We just talked about that. Enhance the overall air quality by combining some of these together. Most systems installed today in new homes, they don't have the luxury of having different compartments to do this. You're going to have to ask a contractor to add additional compartments for another filter, or drill holes and add power for the UV lights. But it's really important in maintaining the IAQ. So health benefits, reductions of allergies, irritants, leading to fewer respiratory issues and allergic reactions. Indoor comfort. So now you're contributing to a cleaner, fresher indoor environment. And then support for HVAC systems. So filters can extend the life of the HVAC by trapping dust and debris before it makes it into the coil and starts clogging up those little pores that are in the coil itself. So once that draws down and the holes are getting smaller, your efficiency starts to fall. So a good way to do this and to understand it is looking at MERV ratings. So off-the-shelf filters can be confusing. So understanding MERV ratings in the system is a great way to help you select the right filter for the priority that you have in mind. So MERV is the minimum efficiency reporting value. It ranges anywhere from 1 to 16. The higher the number, the smaller the particles captured. How to choose the right MERV for your home? Well, assess your needs. Is it common allergies you're looking at? Is it dust levels are too high? You might live on a dirt road, or you might live on somewhere that's got a lot of dust in the air, not a lot of houses around protecting you from other just the air moving around. Odors, is that a concern? Or is there other health concerns as well? So balance airflow to filtration quality. So higher MERV traps more, but it restricts airflow. So the impact on the HVAC system can reduce efficiency or cause damage. So you have to look at it by, a lot of people would say if you had, there's MERV 11, MERV 13 filters that are 1-inch thick, but if you take that out and slide it into a system that's from the 1990s, your chances of killing that system is going to be much higher, and you're burning out the air motor in there, the blower motor, because it's not made to go faster due to restriction. It's got one speed and one speed only. And if it's got restriction, it's now producing more heat, heating up the bearings as it turns because you don't have enough airflow going through it. The fan is trying too hard in a sense. And so it's going to shorten the life of the blower motor. So higher the filter, you got a problem with it. If it's pulling out too much particles, it will get dirty much faster and have to be changed at a much higher intervals. Most houses today that I saw, they throw in the, usually it's about a MERV 9 or a MERV 10 4-inch media filter. They tell you that it's a 6-month filter and it shouldn't have to be changed more than 6 months. That's just a rule of thumb. Yours could get dirtier faster, or it could actually last longer. But not knowing when it's clogged up, it is a big disadvantage to the efficiency of the equipment. I hope in the future, I know these systems are out there, but having a monitor, and we'll talk about some things that are in the future ahead of in other slides, but you can be able to know what the static pressure is. And if you know the static pressure and it starts to raise or lower to extreme levels, it's time to change the filter. So lastly, of course, I just kind of mentioned that a little bit, but buying higher MERV filters may work in your system, but it may reduce the airflow, causing equipment damage or higher than normal energy consumption just for that fan unit to turn. And on that lower left, you can see kind of a snippet I got off the internet. It's just showing the MERV ratings and kind of what each one of them do. The 13, which is the highest, it takes care of everything that's on that list, but your system may not be able to handle that. Even a new system in a new house may not be able to be set up and designed to run at a MERV 13. So you'll have to check with your manufacturer of that equipment or a contractor to look at it and say, could I put a higher MERV filter in here without hurting or harming my system? They could do a static pressure check and they will tell you that yes, you could, or no, you couldn't, or yes, you could, but you need to make sure you change the filter more than, more times than just once every 6 months. Maybe that's a yes, but your media filter is now every other month. And those things aren't cheap, so that raises the cost of maintenance, but it's those things you have to consider. So best practices for basically building design for optimal IAQ. So the design of that plays a pivotal role in determining indoor air quality. So you've got design strategies like whole house systems, you got zoning for air quality, you've got maximizing the natural ventilation. So positioning windows, doors, and vents, strategically placing the windows on what you normally have in airflow outside. More windows on the east and west, if that's the way the airstream is going through your environment outside, or south, and it just depends on kind of where you're at and what's around you. If you're trapped in between two houses, you may not have a lot of airflow happening between houses, but front and back, you probably have more. So having more windows, which most houses do on the front and the back, but if it's just the opposite, and you've got trees trapping you in the front and the back, you got more windows on the side, you can strategically position windows and doors. Also, maximizing the airflow, vent placements if you've got vents for just that. And then material choice and the impact on IAQ. Use low VOCs, use moisture resistant products, and then sustainable and natural products as much as you can. And no one's saying that natural is all perfect, but it's better than the chemicals that are actually in there. So by incorporating thoughtful ventilation strategies, strategically position windows, doors, and vents, and choosing right materials, we can significantly enhance the indoor air quality of our homes. So these elements are not just individual factors, but also part of a synergistic approach to buildings being healthier and better and healthier living spaces on the inside. So just a quick little run through on just material selection. So identifying low VOCs, and again, I keep telling everybody, if it's low VOCs, that means it does have VOCs. It's just on the lower scale, but there's still contaminants in it. So you need to still have proper mechanical ventilation. But look for products that are labeled and certified, such as the Green Guard that we talked about earlier, or low VOC labeled. You've got InterNACHI, which is a real estate inspecting group. They actually have their own inspector certifications for specifically indoor air quality. So that's good to have. The EPA has Indoor Air Plus, and it shows to be a qualified home. So if you got that label on your house, it has been tested and verified that it meets the Indoor Air Plus of EPA standards. And then you've got Energy Star, which also kind of has that linked together. And then LEED, we talked about that a little bit. It's just an above code program, has an interior environmental quality. There's a checklist that you have to go through when you're a LEED inspector to make sure that you're meeting all of these things. Either that or it's a certain level, and you actually are making sure the home's interior environment meets the air quality that's required by LEED certificates or LEED certification. So best construction practices also to improve IAQ. You got construction techniques that minimize indoor pollution, low emitting, low VOC products, moisture control, off-site fabrication, phased installation. So off-site meaning, the things that you're putting in has been built somewhere else. It has had time to off-gas. So a lot of times high-end custom homes may have custom cabinets built on site. Those now need to have a time to off gas and also be able to, settle into the home itself. But if you bring in cabinets that have now been shipped around the country, those have usually off gas on their own because they're prefabricated off site. And then you got phased installation, like sequencing the installation of materials to minimize contamination, like installing carpets after painting and finished work. And then best practices for storage and use of material. Keeping materials dry, covered to prevent contamination and degradation. Storing wood products off the ground. So in LEED, that's a big thing. Wood products, even wood framing, can't just be in contact with the ground. It needs to be held up off the ground and or covered to maintain that so it's not degrading or has any degradation to the product itself. And then safe handling is ensuring proper ventilation to use when using high VOC products, and then following manufacturer guidelines for that use. And the material tracking and management. So that's become a bigger and bigger thing when you look at above code programs and you're looking at higher indoor quality certifications, is keeping record with the inventory of those materials and the tracking of those materials of where they've been, what they've been subject to. Because we all know wood absorbs moisture, but if it's been around a contaminated job site, it can also absorb some of that moisture that's laden with pollutants that now will off gas over time. And then importance of dust control and site cleanliness. So dust control techniques using tools to extract dust, wet cutting methods for tile and masonry, not to just airborne all this stuff. I don't usually see that happening in construction for, just high-end, high-volume homes. It's usually they're just dry cutting a lot of that stuff. And then regular cleaning, so implementing daily cleaning protocols to reduce accumulation. I know a lot of times with pre-drywalls, there's a lot of builders that have a policy where you always have to have it broomed out or blown out daily to keep contaminants low. That's a great way to do it. There's others that just don't have that as their priority. So there's a ton of contamination. There's a ton of products that get trapped inside the walls and or behind bathtubs or trapped in the seat of the shower. That stuff just will off gas over time. And then air quality monitoring, we'll talk more about that later, but utilizing air quality monitors during construction to detect and address pollution sources promptly. I've never actually seen that being used, even if it's a LEED house. I think that's something you probably could do, but it's not that you have to do. And like with LEED and Energy Star, they want the ducts to be sealed with some sort of method to not have contamination build up inside the ductwork. So they have to be taped throughout all of construction. So a lot of this stuff can be done. I just don't see it happening a lot, but more could be done to lower contamination and indoor pollutants inside of a house. Another one is pre-occupancy building flushouts. So this is not required by code, but it's an above code program. Like for LEED, it's a requirement. So there has to be a certain amount of time given to pre-flush the house or have a flush out. So opening all the windows and doors and leaving it that way for 24 hours, letting things off gas and letting that contamination exit the building itself. By methodically removing or significantly reducing indoor air pollutants through this process, you set a good foundation for healthier indoor environment from day one. So this practice not only demonstrates the commitment to indoor occupant health, but it also underscores the importance for considering air quality in every phase of the construction. So just finishing a house and then having things there is one thing, and then vacuuming the carpet, and then you mop or sweep the floors and you clean things up. But things that are trapped in the floor itself. I have an older home. I just recently removed all of my carpet and actually installed vinyl flooring, which I think is better and it's cleaner and it may be better for your health, or it may have off gassing on it. I'm not sure. But when I pulled the carpet up, point to that was just behind all the tack strip was just piles and piles and piles of contaminated materials. And of course, a lot of it was just sheetrock dust, but there was glue, there was polyseal, there were, of course, dead bugs, and then metal pieces and wiring. There's just things that are all trapped. So none of that was in the past. Nobody made sure they vacuumed all that out before they put carpet in. So just a little things again, just going through some of that. But again, just reiterate, this is not a code requirement, but it should really be done, in my opinion, it should be done on every house and every building before it's occupied. It should have a pre-flush done before occupied. And as I said a second ago, with LEED, it is a requirement that you do that. So regular maintenance and sustained for better sustained IAQ, you got HVAC routine servicing. We've talked about that a minute ago. Duct cleaning, we talked about that a second ago. But just looking at ductwork and getting it cleaned. I don't know what the intervals are. I'm sure if you talk to somebody that does the service, they'll want you to do it annually. But what's a good rule of thumb? Maybe once every 4 years, maybe once every 5 years, cleaning the ductwork. If you're buying a house and it's an existing home and it's an older house, it probably would be in your best interest just to get duct cleaning done before you occupy the home. Allow the system to run to bring some of those particles out of that duct system. And that would be a good way to try to reduce some of that dust in the home and contamination, because the other homeowners may have had a pet. There's a lot of pet dander inside that, and you may not have a pet, but you're going to feel the effects of that. Checking for leaks and damages, regular inspections for leaks of ductwork, which can draw contaminants from the attic, the crawl spaces, the basements. And then regular filter changes. We talked about that when we talked about filtration. It could be 3 months. It could be every 6 months. It used to be when I had this house built in '94. I mean, it was every 30 days. We had a 1-inch filter, and you did it every 30 days. But I was a homeowner that didn't know anything, and I actually went out there and bought the highest and most expensive 1-inch filter I could with the highest MERV rating. I've now changed my system. The system did not fail on me, but it could have, just due to the fact that it was too high of a MERV for that system. So choosing the right filter is also very important. And then cleaning the vents and registers, so not just the ducts themselves. Registers and vents also start to accumulate and trap contaminations and dust accumulation on those. And then, of course, having a routine home inspection. You could have, as we saw earlier with Internashi, they have a certification that someone probably has already taken all the testing, had all the training. They can come do a home inspection. Even if you may not be selling the house, they can come just inspect it for indoor air quality issues. They can detect things like high humidity levels, ventilation issues, mold growth, and then kind of give you an idea of what you can do to actually counteract that. So they'll also give you suggestions on regular monitoring of the IAQ. There's a lot of things that are out there. We'll talk about that more in just a second, but going through what's out there and what's available. And then, of course, you can have what's called a professional IAQ assessment. So the value of the periodical professionals for the assessment is they do a comprehensive understanding of the home and the air quality that's there. They may even set up sensors that have to be in the home for up to 72 hours. It's accumulating data throughout the days and the running of the home and the conditioning of the house and how things are going through it. it collects data on what it seems. It's not just an instant. They can't just walk in with one hold in the air and say, yeah, you've got poor indoor air quality. I mean, there might be one that can do that in an instant because it's picking up something like CO levels or other issues that are in the air. But for longer term, you'll have something that sets up in the house to actually monitor it over time. So the journey to maintain excellent indoor air quality is ongoing. It's heavily reliant on regular and diligent maintenance, from servicing the HVAC systems to routine filter changes to consistently performing home inspections, either by as a homeowner just looking at things or hiring someone to actually come in and do it. So these practices not only contribute to a healthier environment, but also enhance the efficiency and longevity of our home systems. So that just goes kind of without saying, is you just kind of look at what you've got there and determine whether or not something's deteriorating. So empowering homeowners through DIY IAQ monitoring. So that's one thing that's kind of out there. There's a lot of affordable tools. So you've got one that will detect VOCs, one that will detect carbon dioxide and carbon monoxide, high humidity levels and temperatures as well, and then particulate matters. I've got a new Ecobee on my wall, and it actually gives me indoor air quality. I don't know at what levels it does. It only lists it either as good, fair, or poor. But I know when we're doing cleaning, and let's say we're mopping the floor or using chemicals to clean the bathroom, it almost instantaneously will start reading a poor indoor air quality. So over time, it cleans itself out, or we open windows and now ventilate, and it allows it to actually do that. So it's monitoring it in real time. They're cost effective. They're smart. They can tie into your smartphone. You can see it in real time, the data that you're actually seeing. Now we'll start plotting things on a chart, and you can see when do things get worse. Most people will probably see that indoor air quality will start to diminish over the winter months because you don't open doors that often, you don't open windows, you don't go out as often. So it's the pollutants start to build. But understanding and interpreting what these indicators are giving you is also key. So read the guide, read the instructions, understand the data that's provided. So a parts per million of one thing may not be bad, but a parts per million of a different level of a different product is a lot worse. So understanding the thresholds, the parts per million, when it becomes an issue for most people. And then recognizing trends. So tips on identifying the patterns as to when, as we said a minute ago, if you're seeing that chart, you can start looking at underlying issues. And then of course, when to take action. So is it an immediate action? If you have a lot of CO2 or CO built up inside the house, did something happen in the home that requires immediate action? Opening windows, doors, turning on air purifiers, evacuating the house? Or is it long term? So recommendations for consistent readings to basically elevate or alleviate pollutants might indicate that the home needs improvements, such as upgrading ventilation systems or replacing certain materials. So people like in my profession, you know a lot about building science, you know a lot about what it takes, and you start doing it to your own home because you realize, well, I need to do it to my house. If I'm preaching that, I need to do it as well. But just realize as you do some of the things, if you don't increase ventilation, you may also make the house a sick home, and now you have more of a problem than you started with. So it's just knowing and monitoring and dealing with that, knowing it can come up. And then, of course, professional consultants are out there. You can ask for professional advice, especially when readings are inconsistent or consistently indicating poor indoor air quality. So DIY is a powerful tool for homeowners that can be used for that. If you don't just have a simple thermostat that now reads indoor air quality, you can get standalones like what you see here. Utilizing affordable monitoring tools and learning to interpret the readings, you can take timely and informed actions to ensure a healthier home. And this empowers through knowledge and technology, not only enhances the immediate comfort, but also long-term for the structure and long-term for the homeowner itself. So innovative IAQ sensors and monitors, we talked a little bit and saw a few of them a second ago, but cloud storage, cloud systems, smart home servers, this is where a lot of this stuff is going now, is having real-time data at your fingertips that's either put onto a cloud-based server that you can look at the dashboards. They're interactive, they're user-friendly. It can throw a trigger warning to the homeowner if it needs to be, air purifiers or a humidifier or a dehumidifier needs to run. It actually lets you know. And this is where I think I see the systems going in the future, is they'll just manufacturers will just start putting this equipment together in their systems and selling it that way because they realize it's an important feature of their systems that they can now upsell. So there are bolt-ons that you can do that bolt on IAQ stuff, but I see it in the future that eventually just buying a standard HVAC system will have these sensors in it that will be tied to a home server or a dashboard that gives you this user-friendly application to see what's going on in real time. So actionable items will pop up, real-time data comes up. So the integration of smart home technology with indoor quality management represents a significant amount advanced in our ability to create a healthier environment. So as we always say, goes hand in hand. When you start doing energy efficiency, that means you're making the house tighter, which means now you're increasing potential for contamination buildup. So I just think this is going to go hand in hand with now we're making houses really, really airtight, really, really energy efficient. So we're going to have to do something about indoor air quality. And we're seeing some of that a little bit with foam encapsulated houses having increased humidity levels. But if you don't have something that tells you that, you just feel the warm air is stickier, but you can't put your finger on it and go, well, I have 70% humidity. You're just assuming something's not right. But in the meantime, you're just turning the thermostat down to basically produce, or you're consuming more energy to offset just the comfort issue. So having that feedback is what's going to empower homeowners with real-time data, alerts, actionable items, and or possibly it will actually trigger a call for your HVAC technician. He may come knocking on your door and say, hey, we got a few alerts that said you have high humidity levels. I'm just here to check to make sure your system is functioning properly. And we're going to actually look at filters, make sure the filters aren't clogged, make sure the air handler is still running at its maximum efficiency. This things can offset some of that and actually lower the causing of having high humidity or contamination in the home. So by embracing these technologies, we can not only enhance our immediate comfort, but also contribute, again, to long-term health and well-being of the building and the occupants. We continue to explore potential of smart homes. Let's always remember that the air we breathe is vital as the technology that helps us monitor it. So it's not that we're just looking at something and saying, yeah, it looks like that just threw a warning. It may be telling you, you probably need to step outside or open a window. It's not just to say, that's weird, that just triggered a warning and just still sit on the couch and watch TV. So there are roles that you also can do naturally. So roles of plants. This was something kind of new to me when I started doing the research for this. I knew plants were healthy, but I didn't realize what a lot of them did. And there's specific plants that do specific things that you can put in your house. So, having house plants, they're natural, they're aesthetically pleasing, but they also enhance indoor air quality. But it's important to remember they're part of a larger ecosystem in our house. They have to have the air moving around it to be able to do some of this. So their air purifying abilities, though beneficial, work best when combined with other IAQ strategies and proper ventilation and filtration. So looking at this, we've got plants absorb carbon dioxide, they release oxygen. Plants can remove toxins like benzene, formaldehyde, and trichloroethylene. I can't say that big word. Plants release moisture to help maintain optimal indoor air quality and humidity. Plants, then it goes into just showing what kind of plants are suitable for certain things. Spider plants remove formaldehyde and xylene. A snake plant produces oxygen at night, ideal for bedrooms. Peace lilies filter out formaldehyde, benzene, and ammonia. Boston ferns are great for removing formaldehyde and acting as a natural humidifier. And then aloe vera, even though it's good for the skin, also removes formaldehyde and benzene. So sounds like those plants might be good also in and around cabinets, kitchen areas where formaldehyde used to be present in the past. You may not have that in your cabinets currently right now, but it seems like these are good things that you can actually put in to actually help purify the house itself. So as we integrate plants into our indoor spaces for their health and beauty and cleaning properties, we must also consider the maintenance they need to ensure this suitable and specific environment. Some of these may be pollutants, not pollutants, but poisonous to animals and or children. So that's another thing to be cautious of when you're putting these things in. Maybe put them higher up to where it's out of reach, but can still function as an air purifier. So we talked about it a second ago, having a professional IAQ assessment. Those are out there. The scenarios when one is needed is persistent health symptoms. headaches, allergies, respiratory problems. After home renovations and repairs, it's always good, especially if new materials, paints, or sealants are used, is get an assessment of the IAQ. And then following significant home damage, if you've had water damage, if you had a storm blow in, if you had mold growth that need to be remediated, if you had a fire damage, these can also now introduce ranges of contaminants inside the house. It can also be good for real estate transactions. So if you're going to sell your house and you know you've done the work for low VOCs, have it assessed professionally to give you a report showing good IAQ and low VOCs in the home could be a selling feature for your house. And then when DIY monitoring indicates problems, if the home has a monitor that consistently shows poor air quality, it may be time to call in professional. So what to expect? You got comprehensive testings. They can do a range of pollutants, VOCs, particulates, mold, carbon dioxide, carbon monoxide, radon, and more. And then detailed analysis. They can expect basically giving you a detailed analysis, probably a pamphlet or booklet of the reports, identifying the actual sources of pollutions, looking at potential health risks, and then you can weigh the odds of, do I need to remove that's here, or do I need to put paint over it with low VOCs and cover up what it's off-gassing? Things like that can be done in some of these assessments. And then a report and follow-up, they can always come back, and after you've done some of your stuff, they can do additional testing to make sure that what you made some differences. And then, of course, how to find and choose professionals. Always look for credentials and experience. Make sure they're certified, have a proven track record, ask for references and reviews, look at their scope of services. How much do they actually do? You don't want someone that's a professional just to hold up a monitor in the middle of the living room and say, yeah, you might have some issues here. They may spend 2 to 3 to 4 to 5 to 6 hours to half a day or multiple days just monitoring what's in the home to come up with the actual reading. It should not and probably will not be an immediate response of, this is the problem that you have. And then, of course, the cost and transparency, understanding the cost of the front of that. In other words, don't let them say, well, if we have an issue, then we'll talk costs. Have them actually explain to you what they're going to do and what how far they're going to take certain things. There's DIY methods for getting started, having monitors for them to be able to handle your reports that you have from your systems. It's good to have a starting point, but their assessments are deeper and more comprehensive. So by choosing the right expert, we can not only identify the root causes of the air quality issues, but also receive tailored solutions for long-term improvement. So it's a good way to get that started. And of course, I could say that with also, if you bought a brand new house, maybe have this done as well and have a full-blown report of what was done, just to verify that, yeah, if low VOCs were supposed to be used, but they weren't, there's a reason for concern. But challenges to do that, of course, off-gassing of new materials, tighter building envelopes. We talked about modern construction actually leads to trapping more pollutants inside the house, trapping more moisture inside the home as well. Inadequate ventilation systems. We talked about the 12, the 15, the 18, you had to have mechanical ventilation, but it wasn't tested for functionality or airflow. Now it is in the 21, but if you're still in an area where it's 15 and 18, those systems may be highly inaccurate and extremely inadequate airflow is coming through them. So having that tested, even if it's not required by code, calling in a contractor and saying, hey, my system has a mechanical ventilation, can you test it for its functionality and airflow when compared to what's needed for this house? They'll tell you whether or not it's actually functioning properly. And that, to me, should be an ultimate goal of any new homeowner. Then you got strategies to overcome. So low emitting materials, optimizing that low VOC emissions, making sure they have they also have zero VOC paints, green certified building materials, enhanced ventilation. So you could, even though your home came with just a simple 6-inch duct on a return plenum, you can go to an ERV, you can go to an HRV, you can go to a different system to actually enhance the ventilation. And then proper installation and sealing, so ensure the house is well insulated and allows for adequate air changes and air exchange. Moisture control, so dehumidifiers, proper drainage systems to manage those humidity levels, especially in bathrooms and basements. And then long-term consideration, regular maintenance, monitoring IAQ, ongoing adjustments that might be needed. That includes changing the filter more often if it's actually getting contaminated too fast and too soon. A newer house probably will have to have its filter changed more often than an older home, unless repairs and improvements have been done. Awareness of emerging pollutants, so stay informed of any new type of air and pollutants that emerges and any emerging IAQ technologies and solutions. There may be something else out there that's not being monitored now that may be monitored in the future. So speaking of that, we've got the next slide here is just talking about future trends. I talked a little bit about what HVAC systems may go to in the future is having these sensors put in. I really see eventually you'll have sensors placed all over that system, even if you have a sensor at every vent and every return, measuring temperature differentials, humidity, contaminations. Eventually, all this stuff will start to happen and take place in the systems that we see out there. So advanced sensors, even wearable indoor air or air quality monitors. So you may have something that you put on a lapel or you put on your belt loop or you clip it onto the side of your collar and you just wear it and it will actually set off an alarm saying that you're in an area that it does not have very good ventilation or very poor air quality. And then you've got AI powered systems. So artificial intelligent algorithms now can predict IAQ trends and automatically adjust the home's environment for optimal air quality. So again, that's just adding more systems to the sensors to the systems. I see AI being a part of it in the future. It's probably going to start out with the thermostat. And so if my thermostat is smart enough to tell me that I have poor indoor air quality, eventually it will be smart enough to say, then I need to turn on mechanical ventilation and pull air in or out of the building to lower that, not making the homeowner do something to change it. The AI algorithm will actually do it for me and I don't have to worry about that. And it's causing the home to be more, have better IAQ for me and me not having to do things to make that happen. So smart air purifiers with advanced filtrations also there. It can start telling you when the filter is clogged. It can read static pressure. It knows the differential between before and after the filter, and it will pop a sensor and say, filter needs to be changed. It may only be 45 days after you've put it in, but it knows when it needs to be changed due to air restrictions, not waiting for you just to change it every 6 months. And then innovations for smart home integration. We talked about, if you were part of our webinars on the 2024, we have grid integration stuff happening. So now we have smart home integration that will probably also be tied to the grid that monitors indoor air quality as well as preventative maintenance, having voice activated controls, things that can happen inside the house. An example of that is like a smart ventilation system that is integral to weather forecasts to optimize indoor air quality. So if it's a nice sunny day outside, doesn't have a lot of outdoor air quality issues, then it may turn outside air on and bring in more. And if it's raining, and yes, I know some of the systems now have humidistats, but if it already has the forecast that it can read, it knows tomorrow will be rainy. So maybe it will bring more fresh air in now, today, when it's sunny outside, and not do it tomorrow because they know it's going to rain all day or a chance of rain all day with humidity being in 100% or around 100%. So then future outlook for that is personalized IAQ solutions. So tailoring air quality management for individual health data. So if the person has asthma, the house can be set up for someone with asthma to lower parts per million more than someone without respiratory issues or a cardiac issue, or if someone suffers from headaches or dizziness. You could set your house up to actually change the way the house is being used and how the system is running to lower that and to actually increase your health and safety inside the building, or at least the parts per million will drop inside the building to have it a lot healthier. So it's evident that the horizon is bright and there's a lot of innovative solutions, from advanced air quality sensors to IA powered systems to integrated smart home technologies. These advancements promise not only enhanced comfort, but also health, and also a new era of personalized and proactive IAQ management, not waiting for the problem. It's predicting the problem that could occur. The future of indoor air quality is one where technology, health, and environmental awareness converge to create spaces that are not just habitable, but actively healthy, promoting. and health monitoring. As we embrace these emerging technologies, the open door to smarter, healthier home and living environments, paving the way for a future where air we breathe inside the house is actually clean and nurturing as nature intended. So, kind of one of those things where we're doing one thing, it's kind of the cart before the horse. We're making it more energy efficient, but we're causing more contamination and pollutants inside the house. But eventually, those two will merge to the point where we don't have this issue any longer. And then summary and key points here. So as we conclude our comprehensive journey through the realm of indoor air quality, it's clear that maintaining healthy air in the homes is a multifaceted endeavor, so integral to our well-being. So from understanding sources of indoor air pollutants, recognizing health impacts, to exploring roles of advanced ventilation, filtration, and smart home technologies, we've delved into the critical aspects of IAQ management. We highlighted the importance of proactive strategies in a building's design, regular maintenance, and invaluable role in both DIY monitoring as well as professional assessments. So as we look forward to the future, embracing emerging technologies and staying informed will be key in our ongoing quest to ensure safe, healthy, and comfortable living environments. So as I said in the very beginning, my hopes about this webinar was just to basically have everyone understand why we have mechanical ventilation, why it's important to test it, why it's important for its functionality and for its proper airflow. We create these problems. We create this issue. We need to solve it, and technology needs to catch up. Codes need to catch up. We need to get to the point where we understand that the tighter the house is, the more pollutants we have inside the home. Do something about it. Don't wait for code requirement. Wait for the fact that it's the right thing to do for indoor air quality. So let's carry forward the insights and strategies discussed, committing to not just inhabit our spaces, but also to nurture them, make each breath in our indoor air fresh and beneficial as possible. So, a lot of people say, I go to different talks all the time and go through training, and a lot of times in these big cities, they say, well, the outdoor air is more pollutant than it is on the inside of my house. And that's usually not true. It seems to be, because you can see it on the horizon, all the fog and smog and things that are out there. But if you actually monitored and collected the data, you probably have a lot more indoor contamination problems. So join us next on our next webinar. We're going to go back through some advanced framing stuff. I just call it an update on advanced framing. We'll have a special guest from APA, the Engineering Wood Association, John Grant. He'll actually be giving a short presentation at the end of our webinar, just to kind of talk about what APA does and how they can help with builders to have a better plan on framing to reduce some of that wood that's actually used. And as I said before, my contact information is here. You guys feel free to share it with anybody. I'll answer phone calls all day long, and even in the afternoons. Builders, developers, third parties, homeowners. If they've got questions and I can help, by all means, just share my information, and I would appreciate that. So at this time right now, like we've done in the past, I will end the webinar recording, and I'll stay online for about 10 minutes if anybody wants to discuss or talk about things that either relates to what we just discussed and talked about, or something else. You're welcome to do so as well. So again, thanks for joining us, and I appreciate you guys being here.